Alright, hey guys, today we're going to talk about trig identities, and so this is probably a little bit new. You've probably seen the trig identities before, but it's actually using them to prove things. So that's going to be a little bit new, but it's actually pretty cool. It's one of my favorite topics. So these just review your trig identities. What are sine, cosine, tangent, cosecant, secant, etc., and your Pythagorean identities. These are going to be really important for you to remember as well. Okay, so let's get to some examples. It's going to be really identifying and remembering what those identities are. All right, so simplify cotangent over cosecant by writing each trig function in terms of sine and cosine. So cotangent I can write as cosine of theta over sine of theta. Over cosecant I can write as 1 over sine of theta. Okay, so therefore I'm dividing two fractions, so then I can simplify that as cosine of theta over sine of theta times, so keep change flip, sine of theta over 1. Alright, to simplify that, I have a sine of theta on the top, I have a sine of theta on the bottom, and then I have cosine of theta over 1, so that just leaves me with cosine of theta. Okay, so that's your final answer. In part B, it says show that the left side is going to equal the right side by multiplying the numerator and denominator by 1 minus sine of theta. So we're going to get into this a little bit more. This is like a proof kind of, but when we do a proof, we can only manipulate one side. That's the key here. Okay, so we're only going to do the left side. So cosine of theta over 1 plus sine of theta. Now this one tells you what to multiply by, but a key here is I see this 1 minus sine of theta on the top there, and I see 1 plus sine of theta, so you're going to have some cancellation here. I have to multiply it though on the top and the bottom, because that's really just like multiplying by 1. Alright, so when I do that, I get cosine of theta, because cosine of theta times 1, minus cosine of theta sine of theta over 1 times 1 is 1, and then I have a minus sine of theta, I have a plus sine of theta, so those cancel out, minus sine squared of theta. Okay, alright, so then on the bottom I have 1 minus sine squared of theta. So if I go back to my Pythagorean identity, I know sine squared plus cosine squared equals 1, so that on the bottom is just going to be cosine squared of theta. I'm actually going to take that cosine out on the top. That's your GCF. I didn't really have to multiply that out. So I have cosine of theta 1 minus sine of theta, so I actually did a little bit of extra work there. Alright, so I have cosine of theta on the top and I have cosine squared on the bottom. So I'm going to take the cosine out here and I'm going to take the cosine squared out there. So I'm just going to be left with 1 minus sine of theta over cosine of theta, and that equals what's left on the right, and I usually just write it again because that's what's left on the right, and I give myself a little check. Okay. Alright, next one. Simplify by writing the expression over a common denominator. So you see here that I have sine and I have cosine, so in order to get a common denominator, I'm going to have both sine and cosine. So I'm going to multiply the left one by cosine of theta, because that guy needs a cosine of theta, and I'm going to multiply this one by sine of theta. This one's going to be a little bit longer. Alright, so I have cosine of theta, 1 plus sine of theta, over sine of theta, cosine of theta. Alright, plus sine of theta, cotangent of theta minus cosine of theta. Oops. Over sine of theta, cosine of theta. Alright, so now I'm going to multiply some stuff out. So I get cosine of theta times 1, so this is all going to be over my common denominator. Alright, so cosine of theta times 1 is cosine of theta, plus sine of theta cosine of theta, plus sine of theta cotangent of theta, minus sine of theta cosine of theta, just doing a little bit of distribution here. All right, so the first thing I notice is I have sine, cosine, and then I have negative sine, cosine. So I'm going to go ahead and cross those out. All right, cotangent here. Cotangent I can rewrite as cosine of theta over sine of theta. Okay, so therefore the sine on the bottom and the sine on the top are going to cancel out. All right, so now let's rewrite this. So I have cosine of theta plus cosine of theta over sine of theta cosine of theta. So that gives me 2 cosine theta over sine of theta cosine of theta. Okay, I can cross out the cosine theta on the top and the bottom, and I get 2 over sine of theta, which is just going to be 2 cosecant of theta. Okay, don't leave it as something like 2 over sine or 2 over cosine. Anytime you have something like that, you want to write it as cosecant or secant or something like that. Okay, all right, last one on this page. It's going to involve some factoring. All right, so here I have sine squared minus 1. Think about that as like x squared minus 1. So how would you factor that? It would be x plus 1 and x minus 1, but the x is really just sine of theta. So it's going to be sine of theta minus 1, sine of theta plus 1. On the bottom, you have a GCF. So I see in both of those terms, I see tangent of theta and then sine of theta minus 1. All right, then on the top and the bottom, I can cross that out. Okay, and I'm left with sine of theta plus 1 over tangent of theta. All right, we can still simplify this a little bit. Okay, so here I have sine of theta over tangent of theta plus 1 over tangent of theta. All right, let's go ahead and do this one first. 1 over tangent is just cotangent. Why does that keep doing that? Okay, 1 over tangent is just cotangent. And then sine over tangent. So that would be sine of theta times, now tangent is sine over cosine, but I'm dividing by that. So that would be cosine over sine. So I'm going to cross that out, and that gives me cosine of theta plus cotangent of theta. You always want to simplify as much as possible. So that would be your final answer there. Okay. All right, so we're going to do a couple more practices. These are going to be kind of like proofs. So these, I actually think proofs are a little bit easier because it gives you what your final answer should look like, okay? The big thing is you can only manipulate one side of the equation. But you should know if you're right or if you're wrong at the end because it tells you it should equal secant of theta. All right, so cosecant times tangent. So cosecant I can write as 1 over sine of theta times tangent is sine of theta over cosine of theta. All right, I can cross out the sine. I get 1 over cosine of theta, and 1 over cosine of theta is secant of theta. And so then all I'm going to do is I'm going to write secant of theta equals my right side, which is secant of theta, so I can check it off. That's right. All right, so next one is sine squared of negative theta. All right, so sine squared of negative theta is just the same as negative sine of theta, and this is because sine is odd, times negative sine of theta, okay, plus cosine of theta and cosine of theta. So notice that here it's going to be negative for sine, but it's going to be positive for cosine because cosine's even and sine is odd. However, when I multiply a negative times a negative here, it still ends up being a positive. So this I can really just write as sine squared of theta plus cosine squared of theta. All right, and we know sine squared of theta plus cosine squared of theta is 1. 1 equals 1, so therefore we're good. All right, same sort of process here. Okay, so what I can do on the, let's actually start on the bottom. All right, so sine of negative theta is going to be negative sine of theta minus, now cosine of negative theta is just going to be cosine of theta, okay, because cosine is even and sine is odd, okay? So what you can do there is, or what I would do is I would just pull out a negative, so negative, and then make that positive, okay? And then you have sine plus cosine. All right, so then up top, sine squared of negative theta plus cosine squared of theta, or minus, sorry, so it's minus, so it's a difference of squares right here. So it's going to be sine of theta plus cosine of theta, and then sine of theta minus cosine of theta, okay, because it's a difference of squares. All right, so here what we're going to have is we can cross out, we see a sine of theta plus a cosine of theta on both the top and the bottom, okay, and we get sine of theta minus cosine of theta, and we still have, don't forget that negative 1 down there. Okay, so that means when I divide by negative 1, every sign is going to flip. So it's really going to end up being negative sine of theta plus cosine of theta. And you want to make it match exactly your right side. So I'm going to rewrite that as cosine of theta minus sine of theta equals cosine of theta minus sine of theta. And that equals the same thing. I do want to go back for a second of how I knew, remember this is difference of squares. I know those are negative, but remember we talked about in the problem just before when I established that identity, that when I have the negative squared, that it's really just going to be the same thing as, let me write it out, as sine squared of theta minus cosine squared of theta. So when I do that, it's going to be pretty easy. It's just going to be just like if I had x squared minus 9, you would break it up into x plus 3 and x minus 3. Okay, difference of squares right there. All right, couple left. So 1 plus tangent and 1 plus cotangent. So I'm going to go ahead and break this up into some fractions here with sine and cosine. All right, so tangent, I know I can write as sine over cosine. So I'm going to write this with a common denominator. So 1 would just be cosine over cosine, and I'm just dealing with the top right now. All right, and then the bottom, cotangent, is cosine over sine. And again, this is going to be a lot right here. And so 1 would just be sine over sine. Okay. All right, so let's simplify some stuff. So up top, I have sine of theta plus cosine of theta all over cosine of theta. And then on the bottom, I have sine of theta plus cosine of theta all over sine of theta. All right, so we're going to keep change flip. So sine of theta plus cosine of theta over cosine of theta times sine of theta over sine of theta plus cosine of theta. So remember, this guy right here has got to flip. All right, so I see this on both the top and the bottom, so I can cross it out, and I end up with sine of theta over cosine of theta. Sine of theta over cosine of theta is just tangent of theta. Tangent of theta equals tangent of theta on my right side, so therefore it's equal, and I proved it. All right, so next one is also two fractions, so I need to get a common denominator here. So that means this first one I'm going to have to multiply by sine, and this one I'm going to have to multiply by 1 plus cosine. Okay? All right, so sine. So when I multiply sine times sine, I get sine squared of theta. Okay. And then 1 plus cosine of theta, and 1 plus cosine of theta times 1 plus cosine of theta. So 1 times 1 is 1, plus 2 cosine theta, plus cosine squared of theta. Okay. Alright, so all over my common denominator, I have sine squared plus cosine squared. Well, I know that's going to equal 1. Okay, so then I can do 1 plus 1, and that gives me 2. 2 plus 2 cosine theta, all over sine of theta, 1 plus cosine theta. Alright, I see a GCF up top, so I'm going to take out that 2. 1 plus cosine theta over sine of theta, 1 plus cosine theta. I can cross that out. And 2 sine of theta is the same as 2 cosecant of theta. And that equals 2 cosecant of theta, which is on my right side. So I can check it out. All right, 2 more. Establishing this identity. So here I have tangent and cotangent, so I'm going to go ahead and write those as sine and cosine in terms of sine and cosine. So sine of theta over cosine of theta plus cosine of theta over sine of theta. And sometimes just remember with these, there's multiple ways to approach it. So it's not always like if I do it this way, there's sometimes other ways to do it too. So don't think there's always one way. All right. So up top, and I'm just going to copy the bottom for right now, secant of theta, cosecant of theta. I need a common denominator, so the left side's got to be multiplied by sine, and the right side by cosine. So there I get sine squared of theta plus cosine squared of theta over sine of theta, cosine of theta, over secant of theta, cosecant of theta. All right, so up top, sine squared of theta plus cosine squared of theta is going to be 1. So I get 1 over sine of theta, cosine of theta, over secant of theta, cosecant of theta. Now, let's recognize for a second, 1 over sine of theta, cosine of theta. Well, 1 over sine of theta is cosecant. 1 over cosine is secant, so I can rewrite up top as secant of theta, okay, that's this right side, 1 over cosine, and then cosecant of theta, that's 1 over sine. So I have secant of theta, cosecant of theta, over secant of theta, cosecant of theta. Now you could have written out the bottom as 1 over sine, 1 over cosine, and done all that algebra, but being able to recognize that will save you some steps. All right, when I divide the same thing on the top and the bottom, I get 1. 1 equals 1, so we can check it off. All right, this one is very similar to what we did on the very first page. So if I have a 1 minus right here, I'm going to want to multiply by the opposite because you see the opposite down here. So I'm going to want to multiply by 1 plus on the top and the bottom. So 1 minus sine of theta, cosine of theta. So 1 plus sine of theta over 1 plus sine of theta. So up top, I get 1 times 1 is 1, minus sine squared of theta. Everything else is going to cancel out. Over cosine of theta, 1 plus sine of theta. All right, so 1 minus sine squared of theta, that goes back to your Pythagorean identity because sine squared plus cosine squared equals 1. So this gives me cosine squared of theta over cosine of theta, 1 plus sine of theta. So I have cosine squared on the top, and I just have cosine on the bottom, so I can get rid of 1 cosine up here and this cosine down here. So I get cosine of theta over 1 plus sine of theta, and that's going to equal my right side, cosine of theta over 1 plus sine of theta. And that matches. So therefore, I've established that identity. Okay, so this is kind of what proofs will look like. I think usually Proofs are a little bit easier than just if I give you kind of like what was on the first page, because you can kind of tell whether or not you're on the right track or not, because you know what your end results should look like. But this kind of gives you an introduction as to what these will look like. Okay, and that's all.